Hello dear students, welcome you all. In this lecture I am going to discuss about the adaptive delta modulation. Adaptive delta modulation. So adaptive delta modulation is basically it is a modified version of a delta modulation that we have discussed in the earlier lecture. Right? We have seen that the delta modulation was suffering from two major drawbacks. The first one was slope overload, right? The second one was granular noise, right? So these are the two serious problems with delta modulation. So in order to solve this problem, this new type of pulse code modulation, it is again a pulse code modulation, it was invented, right? So before proceeding further, I want to recall that peak of slope overload and granular noise that we have discussed in the earlier lecture, right? So you can see here, right, what I was talking about. Yes, you can see here what was a slope overload and this is granular noise. So I have explained these two things in the earlier lecture, that these two are the serious problems with the delta modulation, right? Slope overload means either we are getting plus delta plus delta plus delta plus delta, or we are getting negative delta negative delta negative negative, so on. So this is positive slope overload, right, and this is a negative slope overload, right? So due to these problems we are not able to encode the information in the proper way. There is a lot of gap between the actual information as well and the staircase waveform that is approximated. So because of it, when we recover this information at the receiver, we are not able to recover the original information. Same thing happen when we are getting either plus delta minus delta plus delta minus delta. It is shown here. This kind of variation, right, is called granular noise, right? I have shown it here and I have explained it in the earlier lecture also. Now in order to address these two problems, we are making the use of adaptive delta modulation, right? So in adaptive delta modulation, I told you here, what is the main difference? The main difference in adaptive delta modulation will be that we are going to adjust the step size, right? Now in case of delta modulation, right, the step size was fixed. Step size is fixed, right? It is either plus delta or minus delta, but here we will adjust the step size according to the requirement. It can be plus 2 delta, it can be plus 3 delta, or it can have any value, or it can be 0, it can be minus 2 delta, minus 3 delta, so on. So in this adaptive mean we are adapting as per the information signal. We are adapting the staircase waveform with respect to the incoming sample signal, and in this way we are able to catch the rapidly either rising or falling information signal, right? So this is the working principle of adaptive delta modulation. Now I am coming to the circuit diagram. The circuit diagram that we are going to see will be more or less same as per the delta modulation, but we will have only one step in addition to it, that is the step size control unit, right? The other things will remain same. I am coming to the diagram. You can see here This is the you can recall this schematic diagram, and it is the diagram of delta modulation, right? It is a diagram of basically delta modulation. Now I am going to make it as a adaptive delta modulation. How I can make it? Simply I will add a logic circuit that will control the step size, right? So for it I will add the logic circuit here. Yes, this one, and similarly this one, right? So this is a logic circuit that control the step size. I can write here step size logic step size controlled logic circuit, right? One input is coming from here and one is coming from here, right? So it is, and then it is going toward this 1-bit quantizer. So this is addition to the the schematic diagram of delta modulation that I talk here. Only other things will remain same. The working principle, all the things are same, but only difference is we are adjusting the step size as per the previously generated step, as well as the comparison error signal. Two factors are responsible for deciding the step size. One is the present error that is coming from here, right? And the other factor is the previously generated step size that is coming from here, right? So other things are same. We have already explained it in earlier lecture. Now, in order to understand how this circuit will work, I am showing you a diagram or graph that will explain the working of this circuit, right? So I am drawing this diagram here. This is the staircase waveform. Right. So now we will proceed step by step here. So this is the amplitude of the step size, amplitude comparison, right? What is the comparison between the staircase step and the incoming signal, right? This is time, this is 0, right? Let the coming signal is, this is 1, 2, 3, 4, 5, 6, 7, right? All these are intervals. You can see here 8 and 9, right? uh, Now you can see here I'm drawing the now signal. in this way we have, this is what, this is x of t, incoming sampled input, and this is the staircase waveform that we are producing from here, right? Sorry, from here, that is coming toward this side, un as un t of s, and x bar n of ts is basically un minus 1 t of s, right? So this is going to be compared with this, right? Here now, as I told you that we are going to control the step size. So the mathematical part, if we go to the mathematical part of the step size, then the step size can be written as it is delta n is equal to modulus delta n minus 1 error signal at time n, right, and modulus closed plus delta naught error signal n minus 1. So this is the mathematics or mathematical expression for the step size at any time n, right? Step size for this circuit, right? Now you have to remember it, delta n is the given time, right? N minus 1 is the previous step, right? What is en? En is the error signal that is appearing here, right? So I have written here the expression for the step size, right? Now let's start from time 0, t is equal to 0. It means n is equal to 0. N is basically the time at which we are taking the sample, right? So delta 0. So you can look at this point. Now at this point, obviously this information signal is higher than the coming staircase, because we don't have staircase. I have already drawn it up to this point, but we are not taking it into the consideration. We are starting from n is equal to 1, right? So we can cut it from here in order to make the better understanding, right? So at n is equal to 0, right, we can say delta 0, so error signal will be, as the signal is incoming signal is higher than x n ts is greater than x bar n ts. So what does it means? Error signal is a positive, e n t s, error signal is a positive, right? So we have seen in the delta modulation, so here en will be positive, right? Positive, right? And this is a modulation delta n is 0, so minus 1 means it is modulus of delta and it is a positive. Now in this particular case, right, this delta naught will not exist. Why? Because we are starting from here, so previous step doesn't arise. This was this is the now starting step. E n minus 1 doesn't arise because we are E n minus 1 means error signal for the previous step. So we are actually starting from this step. So this term is dropped here. So we are getting delta 0. We can say that is equal to delta positive plus delta, right? So you can see here delta 0 means plus delta. That's why I have taken this erase, right? So this is now positive step. So I think the thing is clear. Now we are proceeding further. Now for n is equal to 1, this was earlier for n is equal to 0. Now for n is equal to 1, we will have delta 1 is equal to modulus delta 1 minus 1 0, right, modulus e 1, right, plus delta 0, right, into what, e 0, right. So now you look at these terms, right? Now E1 means the error signal at this point of time. So error signal at this point of time, you can see now the x of, you know, bar n ts is greater than x n ts. So it means it is negative, it is above, right? So it is negative, so this term is going to be negative, -1, right? Negative, we can say. And delta 0 is what? Delta, right? So plus, but is delta 0? Delta 0 is a, you can say delta 0 is a delta. You have written it here already. So delta into -1 minus delta plus, right? Delta, right? That is equal to 0, right? So what we did? I put n is equal to 1 in this equation. So I got 1 minus 1, 0, delta 0, right? Into E1 plus delta 0 into E0, error signal at 0. So error signal at 0, right? At this interval, we have taken that error signal at 0 interval is a positive, right? We have already assumed in this step that the error signal when n is equal to 0 is a positive. You can see here E0 is equal, not E0, you can write it in this way, E0 is a positive. We have utilized it here. So E0 positive, so delta 0 is a delta positive. So I put the value, so I got delta 1 is equal to what? I got delta 1 is equal to 0, right? So this is the, you know, for the first step. Then for delta 2, right? What will be the, you know, delta 2? You can put the value of, 2 here. So in this case, you will get delta 2 means delta 2, or I can write here for n is equal to 2. For n is equal to 2, delta 2 is equal to what? Modulus of delta 2 minus 1, 1, modulus E2, error 2 plus delta 0 into error 2 minus 1, 1, right? So now you can put all these values. Now delta 1 is a what? Delta 1 is a 0. So it means this terms becomes a 0. What is delta 0? Delta 0 is a positive delta. And what is E1? Right? Error 1. Error 1, you can go here. Error 1 is a negative. Right? So you will have a, minus delta naught. Right? Minus delta naught means minus delta. Right? So in this way, you can proceed for the next step. For the next step, you will have a delta 3. So for delta 3, for n is equal to 3, now you will have delta 3. So you can look at a delta 3, right? Here I didn't take E2 into consideration because delta 1 is equal to 0. So this terms already becomes 0. Otherwise, if you look at the, this point, then the error signal is a, but it is a higher than this. No, it is higher than this. Yes. So at this point, right? So obviously it is positive. E2 is a positive. So now delta 3 is equal to what? Delta 3 will be, you can see modulus of delta 3 minus 1 delta 2 modulus E3, right? Plus delta naught into E2, right? Here it was E1, so obviously n minus 1, so it is E2. Now you can put the value of delta 2. Delta 2 is what? Delta 2 is minus a delta naught, minus delta, sorry. And what is E3? Error signal at this point, E3, right? So if you look at E3, right, then at E3 it is a higher than this. It means error signal is a negative. So it is minus 1, right, plus delta naught. But is E2? Error signal at 2. So error signal at 2 is again a negative, right? So now it will give you what you will get, minus 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 plus, plus delta, and minus delta naught means delta minus a delta. So it is equal to 0, right? So you got the same thing again. So for n is equal to 3, the step size delta 3 is equal to 0. Similarly, you can calculate for n is equal to 4. So for n is equal to 4, I am writing here n is equal to 4, right? So for n is equal to 4, you will get a error signal. You look at the error signal first. N is equal to 4. So error signal is a again it is positive because it is a higher here. So error signal is positive. So n4 means delta 4 is equal to modulus delta 3, n minus 1 means 3 into plus positive plus 1 error signal plus delta naught, right, into what is delta 3? Sorry, not delta 3 but E3 will be there. E delta naught into E into n minus 1 means E3, right? So E3 was plus 1, so you got now from here delta 3, you put the value of delta 3 is 0, right? Yes, delta 3 is 0, so it doesn't matter whether it is positive or negative, plus delta naught into E3. E3 is what? Positive. So, right, you got plus positive delta means plus delta, right? In this way, we can proceed to the n is equal to 5 step. Now I am also drawing the resulting waveform that we obtained, staircase waveform that we obtained after adjusting the step. Now initially it was the waveform that we have obtained, from the delta modulation. But now I am adjusting the step size. So now look at here, delta 0 is equal to plus delta. So it is here plus delta. So we have taken it here plus delta, right? Then but is at 1 is 0 means no change. So we will proceed as it is, right? So at delta 2 it is minus delta means we will come down here, minus delta means we come toward this side. Then at n is equal to 3 we have a what? 0. 0 means we will proceed same way, right? N is equal to 3. Now add in n is equal to 4 plus delta, right? So this is the now resulting waveform, right, that we are going to obtain. Here I think we have mistaken one thing, that is the error signal at E is equal to 3. I think here E3 I have taken it negative but it was positive, right? So here we should correct it. E3 is positive because you look at here, the information signal is higher than the resulting step. So it is positive. E3 is positive. Error at this point is positive. And what is delta 2? Delta 2 is negative delta. But when we took the modulus, it becomes a positive. So that's why positive, positive, positive. There is no problem. But there was problem with the error signal 3 that arise because we were not drawing the resultant waveform simultaneously. Now we arrived at this point, n is equal to 4. Now go to the n is equal to 5 step, right? So I think this glitch that we have created here, now it is sorted, the problem is resolved. Now I am going further for the step n is equal to 5, right? So for step n is equal to 5, right, n is equal to 5. Now you can see here n is equal to 5 means at this point, first of all, for n is equal to 5 we have to take up to this point, right, this the resultant waveform, right, at this point. Now at n is equal to 5 you can see, right, error signal is a positive, right, n is equal to 5. So n is equal to 5. So actually here in this graph, whatever I am drawing, this should be above this graph. So I can correct it. In order to understand it, I am going to right. So now I can redraw it. I am doing it in order to adjust with these mathematical calculations. N is equal to 4 this way, right. Now only then you can see here at n is equal to 5, error signal will be positive because the information is higher than this signal. At n is equal to 5, the corresponding value of signal is higher, right. So at n is equal to 5, the error signal is higher, right. So now I'm writing this expression, delta 5 is equal to modulus delta 5 minus 1, 4 into E, right, 5, that is positive. Error signal is positive, plus delta naught, again I mistaken, E, error signal n minus 1 means E4, right. So E4 is positive. Yeah. So now delta 5 is equal to delta 4 is what? Plus delta. So plus delta or minus delta doesn't matter because we are taking the modulus. Error 5 is positive, so it becomes plus delta naught into E4, right. E4, error 4, error at the fourth interval, it is positive, right. Error 4 is again positive. Yes, error 4 is positive. We have taken it here. Error 4 is positive here at this point. So we are taking it to plus delta, right. Delta naught is also delta and E4 is positive. So we are getting what? 2 times delta. Now this is what I was saying in the beginning. Now the step size is adjusted and now it becomes 2 times of delta, right. So when it becomes 2 times of delta, you can see here this will become, right, 2 times of delta at n is equal to 5, right. Now 1 2, so I think it is 1 delta, I overshooted it, 2 delta at this point, up to this point. Now we are going to n is equal to 6. Now n is equal to 6, you again you can see that n is equal to 6. Now error signal is again positive because this is higher at this point. This is quite higher than this staircase waveform. So for n is equal to 6, right? Let's see what happened to n is equal to 6 value. So n is equal to 6. N is equal to 6 means delta 6 is equal to modulus delta n minus 1 delta 5, error signal 6. It is positive plus delta naught into E5, right. So you can see from here delta 5 is what? 2 delta and it is positive. So it means plus 2 delta plus delta naught means delta. What was E5? It was positive. So 2 delta plus delta, it gave me 3 delta, right. This is very, very important. So at n is equal to 6, you can see from here, right, that we have a 1 2 step and a 3 step. Similarly, you can see when you will arise at n is equal to 7, you will get 4 delta. Similarly, for n is equal to 7, I am not writing it, n is equal to 7, you will get delta 7 is equal to 4 delta. 4 delta means you will add 4 steps here. 1, 2, 3 and 4 up to this point, right? So now you can see what I was saying in the beginning. Now you can see from here, by adjusting the step size, now we are catching the information signal. We are catching the the staircase waveform is catching the incoming sample signal, right? So when we will decode this signal, we would be able to detect this information, right? Earlier it was not catching, it was rising. I can draw it here also. Earlier it was rising in this way, right? It won't be able to, in this case, it won't be able to, catch the information signal. It will catch the information signal at this point, but here it is able to catch it here, right? So this is the difference that I talk about in the beginning. Similarly, this was the slope overload problem. Similarly, you can see at n is equal to 8, n is equal to 9 and n is equal to 10, right? You can see when we will n is equal to 7, we will get 4 steps, right? And at n is equal to 8, right? When you will calculate n is equal to 8, now you can see at n is equal to 7. So at n is equal to 7, now the ADM, adaptive delta modulation, is higher now. So now at n is equal to 8, when you arrive at n is equal to 8, right? So obviously again you will make the comparison. So at n is equal to 8, you will again add up here, right? Now n is equal to 7 and n is equal to 8. Yes. So again you will do the comparison. So similarly you can find the n is equal to 7. So n is equal to 8. So at this point again it is higher. So again it means one more step will be added, and so it will become, earlier it was what, 4 steps. So it will becomes 5 steps. At this point 1, 2, 3, 4 and 5, right? But when you go to the n is equal to 9, right? So now at n is equal to 9, now the error becomes negative, right? So what will be the result, right? N is equal to 9 means we now come back. So I am drawing it, you will come back down, right, in this way, right? Then after, in this way you can proceed here. Now this you can see. So you can see the resultant waveform that we are drawing. You can do it by following the same analogy that I followed here, and you can see that both the problem of slope overload as well as the problem of granular noise. Here it was a granular noise, right? You can see here this and this resulting waveforms. Now the plus delta, minus delta, plus delta, minus delta problem is resolved here, right? Whereas the problem of plus delta, delta, plus delta, plus delta, plus delta, or minus delta is also resolved. So this is the way of the working of adaptive delta modulation, right? And this is the mathematical expression or mathematical equation that I utilized for writing down all these waveforms. So as far as advantages of this adaptive delta modulation is concerned, we know very well that what are its advantages. Obviously the advantages includes the reduction in the noise and distortion in the resultant waveform that is generated, that the digital signal that is generated. It also reduces the required bit rate and the channel bandwidth for the transmission of pulse code modulated signals. So this is the best type of the pulse code modulation that we discussed in this topic of a pulse code modulation. Earlier we discussed simple pulse code modulation, then we went to differential pulse code modulation, then to delta modulation, and finally to the adaptive delta modulation, right? So thank you very much.